So from this class onwards, we are going to see the development of individual chambers of the heart and the septation of the heart. So here we are going to see in this video the development of the atrial chambers, that is the right and left atrium, and the interatrial septum formation. So basically, what is the septation process? It is nothing but the division of the heart into two halves. So this process begins in the early of 5th week and ends in 8 weeks. And by formation of 3 septae, the heart is divided into right and left chambers. The interatrial septum divides the heart into the right atrium and the left atrium. And the formation of interventricular septum will be dividing the primitive ventricle into the right ventricle and the left ventricle. And the formation of aorticopulmonary septum will be dividing the bulbous cordis into two tubes, that is the pulmonary trunk and the aorta, connecting to right and left sides of the heart. So how does this septation occur? The septation can occur with the formation of endocardial cushions or without the formation of endocardial cushions. So in the formation of endocardial cushions, there is extension of this cardiac jelly. This is the cardiac jelly around. This is the endocardium. This is the myoepicardiac mantle or the myocardium that has been formed. So the mesenchymal cells which have settled in this cardiac jelly, they proliferate and grow towards each other to form a septum or a ridge, dividing a cavity into two, or only from one side the proliferation can occur and join the opposite side to divide the cavity into two halves. This is what is seen in the interatrial septum and aorticopulmonary septum. So without endocardial cushion formation is seen in the interventricular septum formation, a part of it. So in this, what happens is there is an enormous growth on either side of the ridge where the cavity will be merging onto each other in the median plane as they enlarge, forming a septum-like structure, dividing the cavity into two halves incompletely. So whenever there is a septum formation without endocardial cushion formation, the cavity is always incompletely divided and has to be completely divided by other sources. So that's what we will see in the interventricular septum formation. So before that, the atrioventricular canal, what is there? The common primitive atrium and the primitive ventricle. First, the atrioventricular canal, which is the connection between the primitive atrium and the ventricle, will be dividing the common ventricle and the atrium into right and left halves. Like having a right atrioventricular opening and a left atrioventricular opening. For that, there are two endocardial cushions, that is superior and inferior, that are formed by the proliferation of these mesenchymal cells, and they approximate each other to form a ridge completely separating the canal into two halves, that is right atrioventricular canal and the left atrioventricular canal. So the formed septum is called as septum intermedium. So once the septum is formed, the right side, from the right half of the atrium, the blood flows into the right half of the ventricle, and from the left half of the left atrium, it is flowing into the left half of the ventricle. By this time, there is no definitive formation of the right and left atrium or the ventricles. So as in when this atrioventricular cushions are being formed to form the septum intermedium, simultaneously there is formation of interatrial septum as well as the formation of interventricular septum as well. So with the formation of the septum intermedium, the atrioventricular common canal now is divided into right atrioventricular canal and the left atrioventricular canal. And how this has been formed is depicted very clearly over here. This light brown color, what you are seeing, is the cardiac jelly. The maroon one, what is the dark brown here, you are seeing is the myocardium. The inner lining is the endocardium, which are the layers of the heart. So these endocardial cells lining the AV canal, this aspect is called as AV canal, which is between the primitive atrium and the primitive ventricle. They undergo mesenchymal transformation and migrate into the cardiac jelly and start proliferating, approximating each other to form the septum intermedium, dividing the common atrioventricular canal into right and left atrioventricular canals. Similarly, these mesenchymal cells also, they proliferate in the cardiac jelly of the bulbous cordis portion as well. Here the importance which has to be remembered is the contribution from the cardiac neural crest cells via the second heart field or the secondary heart field, because secondary heart field is responsible for the growth of the outflow tract and the development of the septal formation as well. So there is incorporation of the neural crest cells in the outflow tract, that is in the bulbous cordis portion, which contributes for the septum formation, aortopulmonary septum, which is a spiral septum. So here the contribution is by the mesenchymal cells, which get transformed into cushion cells, and the neural crest cells. Here it is only the mesenchymal and the cushion cells that are responsible for the formation of the septum intermedium. So these endocardial cushions, as said earlier, are anterior and posterior, as you see in the formation of the septum intermedium. They can be right and left, and the ventral and dorsal as well in the bulbous cordis formation. There is a difference in the formation of proximal bulbar septum and the distal bulbar septum, which will give the spiral appearance of the aortopulmonary septum, which by which we can see the aorta being twisted onto the pulmonary trunk and the developed heart. So here INT what?
Hamlin.
అట్లా శబ్దాలు చేయ So after the atrium that is being displaced dorsally and cranially behind the bulbous cordis and develops on either side of the bulbous cordis transversely, and thus bulbous cordis is moved on to the median aspect to have its anatomical position. That is where, when the transversely oriented primitive atrium is in connection with the bulboventricular cavity via the atrioventricular opening. This still is called bulboventricular cavity because there is no demarcation yet formed differentiating the ventricle from the bulbous cordis. So this whole cavity, which has the proximal part of the bulbous cordis, which is destined to form the right ventricle, and the primitive ventricle, which is destined to form the left ventricle, together is called as bulboventricular cavity. So this primitive atrium that is being formed is communicating ventrally with the bulboventricular cavity through atrioventricular canal. This atrioventricular canal, initially it lies between the left side of the primitive atrium and the future left ventricle. Subsequently, the canal gets shifted to the right and comes into alignment with the future right atrium and the right ventricle, which is where the endocardial cushions start developing. So the rightward movement of this canal results from obliteration of internal protrusion of bulboventricular ridge. In the previous class, we have seen there's a bulboventricular ridge or the flank, which is between the proximal part of the bulbous cordis and the primitive ventricle. So with the degeneration or the obliteration of that bulboventricular flank or the ridge which is present over here, the atrioventricular canal will be moved on to the right side, where it becomes aligned with the right side of the atrium to the right ventricle. From the ventral and dorsal walls of the atrioventricular canal, the mesenchymal cells, they proliferate to form ventral and dorsal endocardial cushions. So that is what we have seen previously. So this is the ventral endocardial cushion, the dorsal endocardial cushion, which they have proliferated and approximated to form the septum intermedium. So this septum intermedium will be dividing the atrioventricular canal, the common atrioventricular canal, into the right and the left atrioventricular orifices. So the primary atrium that is still present at this early stage is having a common atrial cavity. So the atrium has not yet separated into right and left atrium by septation, interatrial septum formation. So here, as the right horn of the sinus venosus gets incorporated within the right side of the primitive atrium, the lung birds have just started to develop and the pulmonary vein has not yet formed. And the left sinus horn diminishes with the formation of this sinoatrial fold to form the coronary sinus, which gets lodged in the atrioventricular junction. So during the 5th week around, the dorsal wall of the primitive atrium, it receives the sinoatrial orifice, which is shifted to the right side by the development of the sinoatrial fold. Primarily, the sinoatrial orifice is large enough and is in the midline, connecting the sinus venosus and the primitive atrium. With the development of the sinoatrial fold at the left side of the sinoatrial junction, this one, so this foramen is shifted onto the right side. So the sinoatrial orifice is guarded by right and left venous valves, which project into the atrium, the cavity of the primitive atrium. So both the venous valves, they unite at the cephalic end, as this is what is the opening of the sinoatrial orifice into the primitive atrium. So the right venous valve and the left venous valve, in its cranial end, they fuse to form septum spurium. This is happening at around 5th week. And caudally, the venous valves, they meet to form the sinus septum, and this septum is formed dorsal to the atrioventricular cushion, that is the septum intermedium that is being formed. So this is what is the absorbed part of the right horn of the sinus venosus, which is destined to form the smooth part of the right atrium, which is called as sinus venerum. So as this is being absorbed along with the right half of the sinus venosus into the right atrium, so all these veins, the vessels which are draining into the right side, are also getting absorbed. So the right common cardinal vein along with the anterior cardinal vein, they form the superior vena cava. So there is an opening of the superior vena cava as well. So this is the opening of the right vitelline vein, which is the suprahepatic part that is been persisting. So that becomes the opening of the inferior vena cava. And the left horn, which has formed into the sinus venosus, is the opening, coronary sinus, the left horn, which has been diminished and reduced to form coronary sinus, is the opening of the coronary sinus within the right atrium. So all this, the whole of this part of the sinus venosus will get absorbed or incorporated into the right half of the primitive atrium as smooth part of the primitive atrium. So while all these changes and remodeling of the primitive atrium has been happening, so it is all set for the formation of the interatrial septum.